Did you say something?
Yeah, this I admit 2-3%. Because,
Okay.
so anybody else has installed is Ubuntu VirtualBox ready?
Yes, Arvind. I am also having the issues for virtual.
VirtualBox or Ubuntu or Hadoop?
Virtual box.
So VirtualBox is not installing. The
No.
Mac, the Mac, Windows.
No, it's a Windows.
Let me check for Manish now. I'll come to.
Sure.
Uh,
Okay.
I, okay. Yeah, sure. Okay. Just sharing my screen. Let me know when you can see.
Yeah, I'm able. Your JPS is resource manager, node manager, right? Two are coming.
Yes. Yeah, perfect.
Okay. So
Just a
did you
second.
try this localhost, SSH localhost, right? What happened? What-
I don't know what happened. Let me see.
Okay, now it's coming.
Can you see the screen or not?
It's coming black and now it's not coming. Okay, it's coming now.
Okay. You, you you can you type if you can see my screen? I was just checking all the services.
I'm able to see, but it's not.
Oh, okay. I can just type
Okay,
in.
okay. Can you type it SSH localhost? SSH space localhost.
I don't know. There is some screen issue, I guess.
Yeah, it's possible.
It's never happened. I'll stop the sharing screen and I'll just connect it. Okay, just give me a second. Looks like my virtual box itself is blank.
Well, I check how you should you fix that
Yeah,
one.
sure. Yeah, sure.
Set one first.
Yes, Arvind. I'm sharing my screen.
Let me-
Can you see my screen, Arvind?
Okay, double click on this.
Yeah, I'm getting this error every time.
Like C++ error, I still am not getting that page. Is there any other pop-up you got it?
No.
But nothing is coming on your main screen. Are you other monitor also?
No, I'm just logged in on the laptop.
That is fine, but I'm not able to see anything as a pop-up, right? Anything, right? What happened? Just you're clicking and nothing happening.
Yes.
I think you're sharing only one window. Maybe you should share full screen.
Okay, okay, wait. It's just asking, do you want to allow this app to make changes to your device, like or
Can,
act on virtual box?
can you bring that window because that window is not coming still.
Uh, because I don't think so. It's
Okay, you allow it. You allow it.
yeah, yeah. I'm allowing immediately. It's coming. The
It is
response.
saying another installer is because multiple instance you run it, no? Right? So you just stop all the one because see, it is saying another installer is already running. Okay.
Okay.
So did you make it the screen one option, right? No, don't click again again. Actually, already it's running in the
Okay.
background. Okay, go to your end task. Okay, see because it's failing, right? So go to your end task, your program like end program manager status like task status. Now we can stop it, kill the task if any task is done.
Okay. I should go to the files and stop it, right?
Not file. Right click on the desktop. There is the like taskbar. No? Taskbar you can go. Taskbar.
Yeah, I think it's a task manager.
Task menu.
Can you see my screen? Hello.
Yes, yes, we are able to see it.
Okay. Now where should I find it?
You need to stop that virtual machine, right? Go down, see it. We start with the virtual machine. If it is there, you can end the task.
Okay. Just a sec. I'm not able to find it actually. I'm not able to find it here actually.
Also, you tried uninstalling and install the virtual machine again. You are getting the same issue, even though if you do the same.
Okay, then I'll try that.
Yeah, just uninstall all the stuff and then start installing the new one. Then you might
Sure.
solve
Sure.
that.
I'll try. If any issues, I'll connect with you.
Sure.
Thank you.
Yeah.
Arvind, can I share my screen? I fixed the issue. Uh,
Okay, okay.
yeah, I can share my screen now. Can you make me as host, please? Can you make me as host, please?
Yeah, yeah.
Thank you. Okay. Can you see now?
Yeah, yeah. I can see.
Okay.
Okay, so what is this thing is coming home slash? I did you add the?
I tried doing Hive, but
No,
that
no.
also failed.
Okay, okay, but one at a time because if Hadoop is not installed properly or running, then you can't use Hive. Okay, go to your Nano Bash RC. You go. Nano.
Okay, just a second.
And this path is wrong, right? It's always the path, and Hadoop you can't use it because Hadoop is not your username. Username is okay.
That's why I removed A and I was doing the same thing.
Okay. First you open the Nano bash RC. Let me check the bash RC.
Okay.
Nano bash RC. Just you type nano space dot bash dot bash. RC. Go at the end. So hive one you remove it. Okay, hive we are not going to do. Hive you remove. Take to DD. Remove it. Yeah, remove this thing. And okay. And home your username, that is fine. All this fine. Yeah. Control X, Shift Y. Enter. Enter. Source command. Source BASHRC. Space.
Source.
Space BASHRC. dot will come.
Yeah.
Okay. Now you do SSH localhost. No, it's together. Localhost together.
Oh, okay.
Okay. Now HDFS name node minus format. HDFS
Space hyphen.
name node space format. No, HDFS name node minus format. It's just minus you remove. Up arrow you use, right, whenever name node. Yeah. Minus format.
Oh, before name node there is no hyphen.
No, remove hyphen. Here. Minus format. Yeah. Or getting the error. So your error is you have not changed anything in the configuration file. It is saying cannot create directory home Hadoop. Hadoop is not your user, right? You have as it is copy pasted configuration, but you have not modified your username. So go to your Hadoop installation folder. Go to in the here etc. Go inside this Hadoop and open the core site.xml. Change this Hadoop to your username because yesterday I told like Hadoop you modify because this Hadoop is for them. Okay. Now save it and close this file and open the hdfs site.xml. Open this. Here also the same problem. The Hadoop.
Even here, right?
Change it. Save it. And then now close this one and go to your terminal. Now again up arrow, run the same command. Yeah, run it. Yeah, now this time no error came, right? Now you do start -all.s. Start -all. Take it together. It's together. Start -all.
Oh, okay.
The one command. Start. Enter. So I told like any configuration things you mismatch it, then you will not be able to start. And now everything is starting properly. Like your name node is starting, data node is starting, secondary name node is starting, and resource manager is starting, and node manager is starting. All 5 services. Now you check JPS. Actually, resource manager, node manager already running. So it need to stop and start. But all 5 now. Now you can check any Hadoop command. So Hadoop fs -ls. Hadoop hadoop fs minus ls. Fs minus ls slash, after ls space and then slash space slash enter. So this is the root directory. Okay. I will do other command because right now there is nothing there in the directory, right? So it's
Okay.
okay, so we are not getting anything. Okay, so when you create a directory and copy the file, then you can, this is your Hadoop file system. It's a virtual file system. We cannot go inside this file system. We have to give always complete path of our directory path, like complete entire path we have to give. Okay, like
Okay.
Unix, you can go inside any directory, right? Because Unix is the local file system, but Hadoop file system is a virtual file system. So always you have to give a complete command. Okay, so your Hadoop is working, and Hive you cannot install without Hadoop. Okay, and you have to create some directory. So you have to follow the Hive installation completely. Then you can
Okay,
copy
sure.
paste the Hive path. Okay.
Okay, thank you.
Yeah. Anybody else having problem? Okay, so Monica, you try your installation, right? This virtual box one, right? So
Yeah.
okay, so yesterday we were talking about
Hi, Arvind. I am also having issue.
which one, and Hadoop or which one?
Yeah, in the Hadoop itself. So after changing the configurations, we need to format the name node, right? There I'm having issue.
Okay, show me now.
Let me share my screen. Let me know when it's visible.
Yes, I'm able to see.
Okay, see here. After changing all the configurations, I'm getting this error like invalid Hadoop and home.
So what is your username?
It's virtual box.
You have not changed.
No.
So software, Hadoop, our home you set it. Core site.xml.
Yeah.
Set it this. HDFS site.xml. Why it is not saved?
Which one?
No, this file you tapped it, but it's not looking saved, right? Star you can see this star not. So did you run it before, or you done the changes and then after?
I do the changes I saved and run it. Yeah, and home. We see the AN file in MapReduce. So I checked in the MapReduce too. Yeah, MapReduce.
Right. So yarn home is here, right? Let's see that.
Yeah.
So yarn is Hadoop home without your this part. Home. See, here is the virtual, okay, home software.
Softwares.
Software is small as much, right? Okay. Home to virtual software. We can check it. Hadoop 3.3.6. This is the your Hadoop home. So if we check the file,
Okay.
virtual box software. 3.3.6. Hadoop home is correct. Okay, one thing is, it is saying Hadoop yarn home, and
Yeah.
here yarn home, right? So how it is picking up this? You have like manually type it these properties or you copy paste it?
No, no, I just copy it.
Enter the password.
Yeah.
Enter password.
Yeah. And invalid operation. Okay. What's that?
No, again you do apt4.
Okay.
So for this is okay. Let's see this file. What is this hdfs mean? So this hdfs file. Okay, let me check it. Okay, this one.
Okay,
What
yeah.
is it?
no problem.
Okay, so we started the basic fundamentals introduction. So what is the block size? Okay, so block size is the in Windows and Unix file system is a 6 KB, but in the Hadoop file system is a 64 MB in 1.x and 2.x and 3.x is 128 MB is the default. So 128 MB is the default block size, and that is also configurable. It can be increased or decreased. So the reason is Hadoop file system is designed for larger block size, so that the files, the large files we can read in the less time. Large files we can read in less time. So let's
You forgot to share the screen.
yeah. So I was talking about the Hadoop file system, right? So we will see that what are the properties of the Hadoop file system, right? Hadoop file system, when we see there are total three core components. So we were talking about name node. We've seen that in the installation, name node, data node, and secondary name node. Okay. So when I say name node is a master, and it is keeping the metadata. So when Hadoop architecture, when somebody is asking you Hadoop architecture, so when you are explaining the Hadoop architecture, so in Hadoop architecture, you have two core components, right? HDFS and MapReduce. Okay. And when you are explaining HDFS architecture, then you will be talking about the name node, data node, and secondary name. Okay, because these are the storage component. HDFS is a storage component of Hadoop, storage component. Okay, and processing component is a MapReduce is a processing component. MapReduce is a processing component. Okay. So when I say MapReduce is again two core component, the source manager and node manager. Okay. So when I say name node is a master node which is containing the metadata about data node. All data nodes metadata is containing at the name node. So name node is not containing any actual data. Okay, but data node contains actual data. So it contains actual data. So data which is the information, like you want to analytics of the data. So that data is stored in the data node, and data node information is stored in name node. So it stores the information like IP of data nodes. Okay, how many number of blocks are there? Number of blocks. Okay, the number of blocks. Okay, and it has all the information related to data node. So it has one heartbeat mechanism is there. So heartbeat mechanism is to check whether the data node is alive or not. So heartbeat mechanism to check whether if data node is alive or not. So here is a high availability concept comes in picture, like how data name node providing the high availability if data node is failure. So in one cluster, if I say in one cluster, right, we have like 10 data node and one name node and 10 data nodes. So if any data node, so here is the application is there. So application is, the default application is 3. Okay, but this can be changed, right, depending on the how critical file we are storing or data we are storing. So if one node is down, one data node is down, okay, then another data node has the same block of copy. So another data node has same block of copy. So this is a complete notes I will provide you. So you can go through and study that notes, right? This Hadoop architecture and name the HDFS architecture. So replication is right, basically providing a replica. So if one node is down to another, so name node is a single point of failure. If name node is down, then entire cluster is down, right? Because you cannot access any data node without name node. The name node is down, then entire cluster is down. Okay, down means like you cannot access anything. Okay, so in that case, they have provided a backup node. So there is a secondary name node as backup node. Backup node. So this one I'm telling, this is Hadoop 1.x. Okay, the secondary name node concept. But in Hadoop 2.x and 3.x, they introduced standby name node concept, high availability one. 2.x and 3.x, they have given extra concept of standby name node. So standby name node is, and one more problem was standby name node. So one problem was with the this backup node, like it takes 30-minute time to sync up. So because we have to sync the metadata. So name node contains metadata, right? Metadata. And this same metadata you should have to sync to secondary name node, right? So the assumption is like in the there are two files are there. One is a fs image file, that is a memory copy. Okay, it's a memory copy. Okay, so whenever your Hadoop starts, so this fs image copy will not be there. And another file is there, edit log file. So edit log file is a disk copy. Okay, so disk copy is a permanent copy, and your metadata is stored in this. Metadata is stored here. Metadata is stored. But when Hadoop is processing, it is using the always fs image copy. because the memory copy is faster, right? Because you have metadata stored in the FS image. So FS image is the memory copy. So whenever your name node starts, like when you start Hadoop, so it loads like metadata, right? Okay, edit log files loaded into FS image file. Okay, so FS image file, it will be loaded. So because of that, you will have the syncing is there. So whenever Hadoop is so secondary name node also having the same these two copies. Okay, secondary name node. But these two copies, like the secondary name node will be also syncing the metadata. Secondary name node is syncing the metadata. So that syncing process is a 30-minute delay time. So syncing process is 30-minute delay. So in Hadoop 1.x, there was an issue. There was an issue in Hadoop 1.x. It takes 30-minute delay. Takes 30 minutes delay to start second name node. Start second name node. So you will not be your request will be delayed 30 minutes, right? You will not be resent request, whatever metadata you stored, you will not be able to find. Okay. So Hadoop 2.x and 3.x, they have given more high availability by using standby name node. So standby name node used to provide high availability, okay, and in yarn architecture. So yet another resource negotiator. Yeah. Yet another resource negotiator. So this yarn is basically high availability in the yarn, right? Yarn architecture 2.x and 3.x. So standby name node is similar to the name node. And one more thing is this name node configuration is higher than the data node because name node is a single point of failure. So name node configuration in any version, it's not a problem. Name node is always higher configuration because it is storing metadata. Higher configuration because it is storing a lot of metadata. Okay, like all the cluster data metadata. So it should be higher configuration and it is used as a single point of failure. Okay. So name node is always a higher configuration because it is storing a lot of metadata and single point of failure. Okay. So here, if I say standby name node is also same as a name node copy. Okay, stand name used to provide a high availability yarn, and it is having same configuration of active name node. Active name node. So here is this passive name node. This standby name node is called passive. So this passive name node will become active when active name node is down. So when active name node down, then passive name node will become active. Passive name node will become active. But it takes only 1 minute time delay. Right? It takes 1 minute to, and it is only 1 minute time request is getting delay only. And the advantage is like it is same configuration, it is fast, and it is same configuration, and it is basically syncing the metadata with some journal node. So one journal node is there. Journal node. So this journal node is a intermediate node between active and passive name. So this active and passive name node, there is a journal node which is syncing the data metadata, which is syncing metadata from active name node to standby name. Okay. So these are all theoretical concepts. I will give you the notes. You will clearly understand this all Hadoop architecture because these are the fundamentals to start the big data, especially for the Hadoop architecture. Right? What is the application factor is there? What is the default value? And what is our application? What is heartbeat mechanism is there. So heartbeat mechanism is like name node is sending a signal. Name node is sending a signal every 10 seconds, every 10 or 30 seconds, something is there, 10 seconds to check, to send the signal, second to send signal to all data nodes. So if data node is giving acknowledgement, if data node is giving acknowledgement, right? It is giving acknowledgement. So it means it is alive. Okay. Otherwise, name node will understand this data node is down. So if any client request is coming for that particular data node data, so it will assign the another data node. So this is basically how read and write happening in Hadoop file system. So how read and write anatomy in Hadoop file system. Okay. So whenever we say how this read and write process is happening, so whenever any client, right, who is either reading a file or writing a file, right, these are the two operations, right? Either you are storing the file or you are reading a data from the file. Okay. So first request goes to the name node. Okay. And name node is having a metadata about that data, right? The file you are requesting to read and write. And name node will find the IPs and block, right? Which block to read or write. So generally, in case of first we go for read. Okay. So when we say for reading data, we need to find the existing IPs and existing block, which block it has to read, because the data is distributed across the node. So whenever the file is written, the data is written into the different blocks in the different nodes, right? Because data is distributed. So first name node will find the IPs and the block number, right? In the metadata, and give this information to client. The next client is directly communicating to the data nodes. There are the then data nodes, and then client will start reading the file, files, blocks, okay, on different data nodes. Okay. So the sequence is maintained, right? Because if I'm saying some file, so I want to populate the same file data, right? Whatever file I have written. If I'm writing this file, so I'm saying this line is here at the third position. So when I read the file, I should get the file in the same third line, right? So suppose I say this much data on the one node, this much data on the one node. So how this all, so name node will be deciding that sequence. So all this information comes to the client will start reading. But some cases, like what happens when client is reading, and suddenly some data node is down. So when client is reading data from the data node, and it is crashed or it is down. Okay. So what happened? So name node is already sending the signal, so it will find which block on this crash data node is available on other data node. Okay. And it will give this data node IP and information to the client. So then client will find the data from that particular data node. Then client will start reading data from other data node for the same topic, data node for same block topic. Okay. So if I go for write operation, so write operation is when you are going writing. So again, contact is a name node. Okay. And name node, it will find the place, like it can place the block, right? Because this will be decision taken by the name node where to place the blocks, right? So it will find the space and it will check, right? Okay, like it has all the metadata of all the data node. So it will be checking depending on the file size, how much size will be distributed. Okay. So name node will provide all IPs information with number of blocks. How many blocks can be written? With number of blocks written on different data nodes. And then client will start. Client means like some command. You are firing some command. Like okay, so that command, the client will be starting writing the data to different data nodes. So this failure situation can be same. Okay. So here reading and writing the failure situation same, but actual thing is the client is directly communicating with the data node once it gets all information from the name node. Okay. So this is read and write anatomy in the Hadoop file system. Okay. So resource manager we were talking about. Resource manager is a master, okay, which is allocating tasks to node manager. Task node manager. Okay, and one more thing is this resource manager in this is Hadoop 2.x and 3.x, but the earlier version it is called the job tracker. Job tracker in 1.x. Okay. And node manager is in Hadoop 2.x and 3.x. Okay, but earlier version it is called task tracker in 1.x. Okay, so you should not confuse because it should be the same only. So this is just a terminology change. But resource manager, because earlier version job tracker is only just allocating tasks and taking care of the task. And this name node, so if a storage thing comes in picture, so only this storage services comes in picture. Okay, like name node, data node, and secondary name node. But whenever any computation task is there, like client is like doing some word count program, right? Okay, just an example, word count program, like some processing task. And for this kind of processing task, it will come to the name node, and name node will talk to the resource manager, because resource manager will be allocating the task to the node manager, and node manager on each data node. So wherever the data is available, right? Suppose I want to do word count program for a one input file, like, and this input file is distributed on different data nodes. So whatever different data nodes this data is present, the resource manager is allocating the task to the node manager on those data node machines. Because all data nodes will not come in the picture, right? Suppose I say my text file is very large text file, and then it is distributed on 10 data nodes. So all those 10 data nodes will be allocating tasks. So one data node has one node manager. Okay. So if I say in the cluster, like I say, one is a name node machine. Okay, it could be a multiple name node machine, right? In case of like a standby name node, right? So these could be our different machines, right? Name node on the, because same machine there is no point to keep it name node, and so stand name node is a different machine, active name node. So one machine is active name node, and one machine is passive name node. Okay. So if this active name node is down, this passive name node will become active. Okay, will become active. Okay, and other one is one machine is a resource manager. Okay. Resource manager, and others are the data nodes machine. Suppose you have 10 node cluster, so other 7 nodes are data nodes, and each data nodes having one node manager. Okay. So this kind of architecture is there. So this all component are like depend, right? If you are doing only storage task, so only Hadoop will be there, HDFS will be. But if you are doing any processing task, right? So Yarn will be there, resource manager, node manager. Okay. Okay, so far it is clear. Okay. So HDFS Hadoop file system, we will see what are the things we have to do next. Okay. So once our Hadoop is installed, right, we have a prerequisite Hadoop is need to be installed. Okay. once Hadoop installed. And next we have to do Hadoop developer command. So Hadoop developer commands are the commands which we run on the terminal. Okay, run the commands on terminal. So why we need this command, right? Run the command on the terminal. Because Hadoop file system, I told it's a virtual file system. So HDFS is a virtual file system. So whenever you want to do any analytics, we need to bring the data into Hadoop file system. Okay. So how to bring the data? So we have to use some command, right? So in the Linux, we know there are the various commands are there. Linux command, we have ls command, mkdir command, cp command, mb command, okay, rm command, okay. So similar to this command, Hadoop file system has given the similar command, but we have to use Hadoop fs prefix. So whenever we do Hadoop fs minus ls, and I say slash, so slash is for root directory. So if I want to create a directory in Hadoop file system, so I will say Hadoop fs minus mkdir and slash test. So when I say slash test, it will create a one test directory inside this root. Now I want to check this directory is created or not. So Hadoop fs minus ls, then I can do slash test. So I will see my test directory is created, or only slash I will do. So I will be able to see my test directory. So this command we have to run. This is the Hadoop file system manipulation command. So suppose I want to copy some file in my local file system to Hadoop file system. So Hadoop fs minus put command is there. So local file system, you should have some file, like I say test.txt is there. And I want to copy in some Hadoop file system directory /test. When I write this, so I will see after this, I will do Hadoop fs minus ls and /test. So I will see one test.txt file is created inside this. Yeah. So these are the simple command. If you are aware, like Linux command, okay, so you can easily understand. These are the ls for the list command, mkdir for the creating a directory, put command is for copying a file, ls command is for list. So there are 20-30 commands are there. Okay, so once your Hadoop is started, right? Once you started Hadoop, like start all.sh, I'll quickly show you some commands. So I will give you the commands so you can practice. So three things we will do in the one is we have a one terminal command. Another one is Hadoop REST call API command. REST call API command we use when Hadoop file system is not local. Suppose I'm running a Hadoop in a remote file system, okay? And I want to run the commands in my local file system. So REST call command is there. So call command we have to use like get post command. If you have heard about the get post put. So this command are there call command. So this way also we can run the same command, but using the curl. So curl is a Linux utility. Curl is a Linux utility, and we can use the curl utility and we can run the curl command. And another third way, we can run the Hadoop command by using the HDFS Java API program. So HDFS Java API program, we can create a program and that can list files, okay, copy file. Okay, so separate program we can get, copy file, remove file. So whatever things we can do with the developer command, same we can do the RESTful command and same we can do with the Java API. But Java API one, the advantage is it's a programmatic approach. It's a programmatic way. Because command line you have to do manually. Suppose I ask you 100 directory you create. So if you do 100 directories, you will be writing mkdir test1, test2, test3, like you have to do the 100 times this command. So two ways you can do automation. Either you can use Java program or you can write shell script. Shell script, you know, automation. If this Hadoop fs minus mkdir and for loop I write, so I can run this for I in 1 to 100, some value I run the loop, and I say mkdir, I can just instead of this test, and I can put $i. The $i, what it will do, it will replace the value 1 to 100, and this shell script I can run, that will do. Okay, so this is automation, right? So command line, you can do one single command at a time. So if you want to run same command like as an automation, so you can use either programmatic way, Java or shell script you can write. So if I want to see my all file system directories list, so I will do hadoop fs minus ls slash. So I will see, because I have created so many directories and this, so it is showing in my, but your case it is coming empty because you have not created anything. Okay? So first you will create a one simple directory, hadoop fs minus mkdir and slash test. So in my case, test will be there. Okay, suppose I give this number, test into 245. So it is, and one more thing is, whenever you starting the Hadoop, so immediately your Hadoop is in the safe mode. So it waits for the 30-second time. So either you run your command after 30 seconds, then it will work. Otherwise, it is like giving this issue. So you can come out of the safe mode. So there is a command hdfs admin minus safe mode leave. So when you do this, this is an admin command. So commands are the two types. One is the developer command and one is the admin command. So admin command we are not using, like this is for admin purpose, but one command is this, like you can know, right, your Hadoop is started and quickly you cannot run any command without this safe mode leave. Now you will run, your directory will be created. So now your directory is created. Now if I do hadoop fs ls, so I will see my test 1, 2, 3, 4, 5 is created. So test 1, 2, 3, 4, 5 is created 9:29. Okay. So this time is the directory is created. Suppose I have some file here. I have some file like test.txt is there. And I want to copy this file, hadoop fs minus put and test.txt. This is a local path. So put command is taking a local path and giving the Hadoop path. So Hadoop path is test 1, 2, 3, 4, 5. And now this file is copied to the Hadoop file system. This test 1, 2, 3, 4, 5. How to see the content of the file in Hadoop file system? So hadoop fs minus cat command. Same command, whatever you use in a Unix file system, but you have to use with hadoop fs minus cat command and say test 1, 2, 3, 4, 5, your directory and slash test.txt. So I told one thing, every time you have to write a complete path because YouTube file system is a virtual file system. So the content of the file is this. Okay, you are able to see the content of the file. Okay, suppose you have to create a multiple directory in a one single. Otherwise, if you say here test 1, 2, 3, 4, 5 is already there, I want to create some test1 and slash test2 directory. It will not create. So it will say test1 is not found. Because test1 is not created, how can you create a test2? So at a time, it will allow a one directory, but there is an option -3. So this is Linux option, not the Hadoop one, but we can use here -3. So it will allow to create multiple nested directories. Okay. Now you see, like if you do ls command, test 1, 2, 3, 4, 5. So you will find test1 is there. And again, you go to the slash test1, you will see the test2, right? So like this way, you can do the file manipulation. If you want to see all commands, just type hadoop fs. You will see this is all list of commands. So these are the total commands which we can practice. This all. Okay. So I will show you the demonstration of the commands, okay, tomorrow. And I will give you the list. You can practice this command because you can see in my YouTube channel, there the other playlist is there. So there you can find this Hadoop command session is there. Okay. Okay. So try this one. Okay. And I will check the issue someone has, right? That issue I will check, right? Yeah, But please install the Hadoop, right? Because if you don't install, then you can't do practice. Okay. Yeah. Thanks, everyone.
Sure.
Thank you.